Hey, good morning, afternoon, or evening, everybody. This is your host, Jennifer Brennan, and I'd like to welcome all of you to the Operation IceBridge Come Discover a Decade of Polar Data webinar. While everybody's logging in here, we do have an optional poll, and you'll find that located at the bottom of your page, and we certainly appreciate your feedback on this poll. I've got 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. First, let's just quickly review a few logistics related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located in the lower right-hand corner of your screen, and this works like a chat. Excuse me. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog, as well as to our NASA Earth Data YouTube channel within a couple of days of completion. And what I'll do is I'll send an email to all registrants that will include both the direct link and also the YouTube link to the recording. In addition, today's presentation files, including the movie files, will be available for download at the end of the webinar. Today's webinar is 1 hour long. We've allocated 45 minutes to the presentation and live demonstration, and then we'll save about 15 minutes or so for the question and answer period. Once our speaker has finished with his presentation, what we'll do next is we'll transition to an optional final set of polling questions. And then after we're through with that, we'll move directly to the Q&A period. And then just one final note, depending upon the volume of questions that we receive today, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. What I'll do now is I'd like to pull up today's agenda for everybody. Let me pull that up. Hopefully everybody can see that okay. All right, great. All right, what we'll do is we'll spend about the first 10 minutes or so with an introduction to the NASA IceBridge mission. And then from here, our speaker will provide an overview of the IceBridge Data Portal, key features and functionalities through a live demonstration of this data discovery and access tool. And then finally, today's webinar will wrap up with information about future developments. With that, it is my pleasure to introduce today's speaker today, Steve Tanner, who is the NASA IceBridge Data Operations Manager at the NASA National Snow and Ice Data Center, Distributed Active Archive Center, or NSIDC DAAC. Steve?
Thank you very much, Jennifer. We're going to share my screen now, so let's make sure that will work. And hopefully everyone is seeing that now. And as Jennifer said, I work with NASA's National Snow and Ice Data Center Distributed Active Archive Center. And that's a pretty long set of acronyms to unwind. So let's start with the Distributed Active Archive Center. For those of you that are not familiar with the NASA DAACs, there's about a dozen of them, and they're physical centers spread around the country that act as the archive for the lion's share of NASA's environmental measurement data. And so it's where NASA makes this data available to the public and archives it for safekeeping. The NSIDC DAAC itself is focused on the cryospheric data, the snow and ice data. So the cryosphere refers to the cold, snowy, icy regions of the world, places like the Arctic and Antarctica, the high mountain regions of the world like the Himalayas, or even here in Colorado, the Rockies. And so that's the area that we focus on relative to the NASA DAAC. So that's, it kind of says it all in the name, the National Snow and Ice Data Center. Now the DAAC itself does a number of things besides just archive and manage the scientific data. And this slide covers that a little bit. It shows that we do manage and distribute scientific data. And we also provide tools for access to that data. Some of the data can be difficult to use. It can be difficult to find and access. And so we try to help users out with various tools for supporting that. Now, in addition to those two roles that you would imagine a DAAC would do, we also have a group of researchers that are located here that work in NSIDC that often go out on their own field campaigns and missions and actually generate some of the data that we then provide. And I bring that up because it's very important for you, the end users, to know that we have this group of researchers here because it allows us to reach out to them, pardon me, when questions come up, because these guys know the data inside and out because they're doing their own research with it. We also support some local and traditional knowledge activities. We have a person or two deployed up into Canada working with some of the First Nations there, trying to make sure that they have some support for their local and traditional knowledge, things like hunting information and those sorts of things that we're trying to help them archive and make available to them for their own use. Now, at the bottom of the screen, left-hand side, shows that we support data users, and that primarily means you all. We have a user support staff here that understand the data, understand all of the products at the National Snow and Ice Data Center, and they also know the researchers themselves, and that's why I said it was important to note that we have a cadre of them here. But they also know the research community too. And so what that means is if you have a question, the user support group is here to help you ferret out an answer to that question, but also knows how to reach out to others should we need more information about it. So it's a really good service, and I encourage you all guys to use it. And that leads into the last thing there, which is because we have all of this information, we do educate the public about the cryosphere. You guys have probably seen some of the postings and some of the information that we produce here. When you're reading press reports and stuff, you'll often see a chart or a graph, and if you look at the bottom, you'll note that NSIDC is very often the source of that. So the DAAC itself does a lot of stuff, or NSIDC itself does a lot of stuff besides just acts as an archive. Now, NSIDC itself also supports more than just NASA. We do receive funding from NOAA, from NSF, and from a number of other organizations. Today, I'm going to talk specifically about the DAAC efforts and the work that we're doing there for NASA. And we are located in Boulder, Colorado, so you can come by and visit us if you're in town. So today, I wanted to talk about specifically Operation IceBridge. And this is a NASA mission that has turned into, I'm not sure it started out meaning to be, but it has turned into the largest airborne survey of polar ice that has ever been flown. It was started in 2009 when researchers realized that the satellite that they relied upon, IceSat, was going to be decommissioned, and IceSat-2, its replacement, was not going to be launched yet, and so there was going to be this gap. And they were concerned about having measurements over the Arctic and the Antarctic during that gap because they wanted some continuity so they could link the data from IceSat all the way through to IceSat-2. And so IceBridge was going to play the role, or has been playing the role, for bridging that gap, thus the name IceBridge. Originally, it wasn't supposed to run as long as it has been running because IceSat-2 was supposed to launch in 2016, but that didn't happen because there's been some technical issues with the laser that they wanted to get ironed out. And so this is a notional chart of what the original charter for IceBridge was all about. IceSat-2 over on the left was decommissioned in 2009, and at the time, IceSat-2 was supposed to launch and be available in 2016, with IceBridge flying in between, as it were. But IceSat-2 was delayed until 2018. You guys can mark that on your calendar. The current launch date is September 12th, 2018. And because of that, they wanted to make sure that there was some coincidence with IceBridge missions itself. So the IceBridge mission has been extended to 2020, so there will be some overlap between it and IceSat-2. That's kind of an important demarcation because it means that IceBridge will be a decadal program, 10 years or more, and that's a big deal. That's a pretty long mission, and so there's a lot of data associated with IceBridge that's been gathered over that 10 years. Now, this notional chart also shows CryoSat-2. If you're not familiar with CryoSat-2, that's a European satellite, and originally it was supposed to be done in 2015, but it's still going strong, so we're not sure when that's going to end. But what you see here then is a pretty nice continuous set of data from IceSat to IceBridge to IceSat-2, and that was the whole purpose of Operation IceBridge. Now, I mentioned it's an airborne mission, and that primarily means using NASA's P-3 and DC8 airplanes, and these are the pictures of both of them. You can see they're pretty big. They're, you know, the DC-8's a big jetliner, and so you can put a lot of instruments in there. You can get a lot of range out of them. They're really good aircraft to use for this type of activity. But two things have occurred and with the longevity of IceBridge. One is these two planes are in high demand for all kinds of other research as well, so it's not always possible to schedule them. The other is maybe we don't need to schedule them. There's lots of other opportunities using other planes that might actually have some advantages. And so IceBridge, being a nimble program, has been able to take advantage of a lot of other planes. For example, the C-130, the Air King, the Falcon, the Gulfstream G5, the BT-67, which is actually a repurposed DC-3, which is kind of cool. It's been repurposed so it can land on the ice and stuff. And then the University of Alaska Fairbanks has a small fleet of planes themselves that IceBridge has taken advantage of. In fact, these guys sometimes land on top of the glaciers, and from our DAAC perspective, that has led to some consternation because we're trying to follow the flight lines, and all of a sudden the plane stops, and so we have to check with them to make sure that they were simply landing on the glaciers and looking about there. So the cool thing is that IceBridge has taken advantage of a lot of different opportunities, and because the instruments, there's a suite of instruments, we can cram whichever ones will fit on whichever plane happens to be available. And so that's extended the range and the number of measurements taken by IceBridge well beyond what just the P-3 and the DC-8 could take. Now I guess it's 2 years ago now, the project office invited a number of us from NSIDC to fly along on one of their flights to Antarctica. And so I was lucky enough to be able to go on that. So here's a little video from that. This is looking at the cockpit of the DC-8. And as you spin around, you see the thing is just crammed full of equipment and people operating that equipment, taking measurements and recording everything. Now, most of the instruments themselves are down in the cargo bay, and these are mainly control consoles and hard drives recording everything that's going on there. But you can see it's a pretty busy place. There's Amy Fitzgerald, who's our user services rep for IceBridge, and there's some of the ATM equipment. And as you spin around and look out the window, this was when we were flying over Antarctica. And you can see it's a pretty flat area that we were going on. But I want to point out that we were somewhere between 700 and 1,500 feet above the ground. So this is a big jet that flies extremely low to the ground. And for a newbie like me, it was a little disconcerting the first couple of times to see how low we were. But it was a very exciting set of flights that we were able to go on. And I want to point out that the instrument people that are on these planes work extremely hard. They wore us out. They were basically flying 14 or 15 hours a day on these planes and then staying up all night to look at their data and make sure their instruments were working and getting everything ready to go the next day. So these guys were just workhorses out there going through this activity. So it was very, very enlightening to go out there and see how the data actually is gathered. Now, I had mentioned that there's a lot of different instruments. So what kind of instruments are we talking about? Well, there's a lot of laser altimeters. There's the airborne topographic mapper, which is very popular. There's also the land vegetation and ice sensor, or LVIS, which is a very cool acronym. But they also, I should point out, they are a team that are based out of Goddard Space Flight Center. And they fly more than just IceBridge. Well, all of these do, but Elvis in particular flies over Africa and Canada and other areas besides just IceBridge. So it's a very versatile instrument, as are the other ones. UTIG is the University of Texas. They have their own LiDAR system. And then University of Alaska Fairbanks also has a LiDAR system. There's also radars out there, snow radar, accumulation radar, a number of different radar systems for looking at, basically they can penetrate to different degrees depending on what you're looking at. There's gravimeters, there's magnetometers, there's also imaging systems like the Digital Mapping System, DMS, which takes thousands of overlapping images as the plane is flying over different terrain. So that's kind of a little flavor for some of the data and instruments that are used. I will say this results in about 70 or more than 70 different products. So there's a lot of different types of products out there that run quite a range of different types of measurements. I'm going to click on, pardon me, I'm going to click on a couple of links here so to point you to some other areas that you may be interested in. This first one is a site at NSIDC that lists all of these products. I said there were 70 plus products. We have a data set page that describes those, and they're grouped together by the type of product they are. But if you scroll down through here, like with the radar data, we list the short name, which is kind of an internal shorthand for us to keep track of the products. But then we also list the long names of the products and give you some idea of where the data was gathered and the time range it was gathered over. And if you click on one of these guys, let's say the KU band, it'll take you to a page that'll give you kind of a quick start use of the data. We'll tell you the spatial coverage, we'll tell you the resolution, we'll even tell you who's responsible for the instrument, and just give you some idea of what you might be getting into with that data. And if you know for sure this is what you're after, you can simply go to the download button and click on that and go get the data directly. And that's most useful if you already know what you're going to go get. But a lot of people don't. And so we have a portal that's set up specifically to help you go through and figure out which parts of the data that you're interested in. Another link is for the Operation IceBridge Project Office homepage at Goddard. And one of the things the Project Office has been doing is they've been very diligent about trying to keep up with the number of peer-reviewed publications coming out of the research associated with IceBridge. And so here, for example, we're talking about 2018 so far, and you can see the number of papers that have been published. There's quite a few. And for those of you that work in the cryosphere, you'll recognize a lot of the names that are in here. This is kind of a small community. But one of the things the project office wanted to do was to make sure that we were able to show the value of the research coming out of IceBridge. And so one of their metrics is the number of flights per paper that comes out. And right now, it's about 2 flights per paper. So every 2 flights, we're getting a peer-reviewed research paper out of it, which is a pretty good bang for the buck when you consider that these flights are reasonably inexpensive. The other thing the other link I wanted to bring up was to point out the IceBridge science team that does the planning and the activities associated with upcoming flights. And I pointed out for a couple of reasons. One is this is the group that you could solicit if you have specific areas you wanted to be flown and areas of particular interest. They do meet twice a year to plan out what the next campaigns are going to look like. I also bring this up to point out that a number of the people on this list, including Tom Newman and Torsten Marcus, are also heavily involved in IceSat-2. And so there's been a concerted effort to have a lot of cross-fertilization between both the IceBridge team and the IceSat-2 team. And they want to make sure that the IceBridge data that's gathered is as compatible as it can be with the research activities that are going to take place as part of IceSat-2. And so those are 3 links that you may want to follow up on and take a look at. I was going to show a couple of videos. I only had time to pull one together, but in terms of using the data, there's a number of videos that are out and about that show some of the results of it. And I accidentally exited the thing. So bear with me while I go back to the video. So this video is one that was taken that the NASA Visualization Lab took of the overlapping DMS images that I had mentioned before. It's important to note that these images overlap because if you're clever with your math and your processing, you can actually derive a 3D image out of that, and that's exactly what these guys did. So this is just taking simple photographs and stitching them together and providing a fly-through of one of the crevasses on one of the ice sheets or sea ice, I should say. And it's kind of a cool way of using some of that data. I think when they released this to the public, they had the Star Wars theme playing behind it to give it a little more punch, as it were. But that's the kind of thing that people are doing with the data that's coming out of IceBridge. Now with that, we're going to go over and we're going to look at the portal itself. So the IceBridge Portal was developed because we realized with that heterogeneous mix of data, it was going to be difficult for users to come in and pick out exactly what they wanted. And so we developed a portal specifically to help them do that. Now, there are other mechanisms for accessing the data. I had pointed out one from the data product landing pages where you can just go download it directly. There's also tools that ESDIS and others have developed, such as Earth Data Search. And Earth Data Search is a fantastic tool for looking at a lot of different NASA data, but it can be a little bit overwhelming, whereas this portal is specifically aimed at looking at just IceBridge data and manipulating that. So when you first bring the portal up, what you're presented with is a polar view of the world, and all of these green lines represent the flight lines where IceBridge has. You're seeing the flight lines, and you're seeing there's quite a few. For example, over Greenland, you can see there's quite a bit of coverage there. And then you can also see where my mouse is. This is where the University of Alaska Fairbanks would be flying out of to head up here. These other lines down here are transit flights. So this is Wallops, where one of the planes generally gets squared away before flying up north. And so you can see these transit flights as well. Now, over on the left, where my mouse is now, we list all of the products that are associated with IceBridge, and you can see it's a pretty lengthy list. You'll see a couple of numbers associated with each of the data products as well. These two numbers represent what amounts to the number of files that we have for each of these products in the Northern Hemisphere. In a moment, we'll go in and we'll look and see what the Southern Hemisphere looks like. But in the Northern Hemisphere, for example, for ATM, Airborne Topographic Mapper, Level 1B data, we have about 17,000 files associated with that. Now, the number on the left represents the number of files that are remained after you have done some filtering. And the two numbers are currently the same because we haven't done any filtering. We haven't filtered out anything. But the idea is to come in and use this portal to filter down the amount of data that you're looking at. And for some of these products, that's not such a big deal. So, for example, with the DMS camera calibration data, there's only 21 files, so it's not such a big deal. But if you look at the images themselves, there's 4 million images in the Northern Hemisphere that are coming out of the DMS instrument. And that's a little bit hard to handle. That's too much to deal with all at once. And so we wanted to provide users with a way to filter that number down. Now, the primary way to do that is to come over, and if you look on the upper right-hand side of the screen, you'll see a number of buttons over here. And these are various filter mechanisms to help you limit what you're looking at. And we can also pan and zoom and some things like that. So let's zoom in a little bit. And this first one that I'm going to look at is just a bounding box where you can draw just a simple box and say, show me the flight lines and the data associated with that particular area. And so it immediately limits it to just the flights that touch that particular bounding box area. And so all of the other flights go away. Now you'll notice a number of things happened over on the left-hand side of the screen too. One, the filtered number went down pretty dramatically because we're only looking at one small area. But two, some of the products actually got grayed out altogether, and that's because there was no data for that particular product gathered over that area. I point out that we grade this out because one of the things we're asking for end users such as yourself is some feedback on this. Originally, we thought that we should grade these out so that you would know there are products in the Northern Hemisphere, just not over this particular area. Pretty much resoundingly, the users have told us they would prefer us just to rip those out so that it would shorten the list. It'd make it easier to go back and forth through this list. So that's an area where we thought we had the right choice, but the user feedback told us otherwise. And so that's why we would very much prefer you guys to let us know any issues or any suggestions you have relative to the portal. Now I'm going to zoom in a little bit more on this area because we're going to start looking at some of the data itself. And for this particular area, let's look at some of the DMS imagery that's there because we've talked about DMS already. If over on the left-hand side, I'm looking at DMS, IceBridge, Digital Mapping System, Level 1B, Geolocated, Orthorectified Images, which is quite a mouthful, but what it means is photographs. And if we open that up, we see the years that DMS data has been gathered over this particular area. And if we open one of these years up, we see that in 2013 there was one day, April 6th, that flew over that and gathered DMS imagery. And if we open that up, I didn't pre-look at this, so it's hard to see. But if you zoom in a little bit, I want to close this so that you can see this happen again. If you look right here where my mouse is, you'll see this area turn blue. And this is where the images themselves were gathered. I'm going to turn off the flight line so you can see that a little better. So you can see these images here. This is where data was gathered. Now for all of the data, if you mouse over these, you'll see some metadata showing in the lower right-hand corner of the screen. In the case of DMS, the metadata includes some browse imagery. So as you move your mouse over this, you get almost a movie version yourself. You can almost make well, actually you can explicitly make a GIF out of these images showing what is being flown over. But we also show some other metadata, the date it was gathered and that sort of thing. So this lets you, here we'll close this one and we'll open another one. Maybe that wasn't quite where we wanted to look. So here's another flight on 2014, and you can see the flight went quite a bit further in terms of gathering ATM data, DMS data. And so it's a good way to go in and explore and see that these are the data that you want. So if you decide this is what you want, all you have to do is over on the left-hand side, if you see my mouse, you can just click and we'll select all of those images and put them into your order queue. Here, I'll unclick it. So blue means these are the spatial extents of that particular data set. Pink means you have selected those for order. And that's useful in case you want to look at a number of different areas because now that you have selected those, you can draw a different bounding box and look at a different area, and you haven't lost what you've currently ordered. So we've drawn a different bounding box with a different set of flight lines that are in it. So this way you can use the portal to explore around and pick and choose the particular items that you're interested in. We can look at some of the other products. Let's see. Because they have different spatial extents. So ATM data will typically have, let's go up here and look at this. So this is some of the LiDAR data. And if you look at it, the spatial extent of each given file is significantly bigger than for the imagery, which makes sense. If you notice on the screen, you should see what looks like a turquoise mouse crawling down the thing. That's the spatial extent of the 3 different granules that are available for that day. over that particular area. And so let's say we want that, so we can go ahead and select that as well. So in that way, you're beginning to build up an order. So we have some data from one area, we have a different set of data from a different area. Now you may have noticed I was doing a few other things, like I was turning the flight lines off and on. So we do that so you can get that clutter out of the way once you're looking at a particular area. You can also turn your own orders off and on so that you're not being bothered by them if you don't care to keep track of those once you've selected them. Now we have some other overlays. This is our overlay window. We have some other overlays that are pretty interesting as well. They can help users when they're trying to explore the data. We have a Mosaic of Greenland file that gives you a little bit higher resolution. We also have a shaded relief DEM file, which has even greater resolution. But we also have some measures data out there, like the velocity map for Greenland at least. And if you're not familiar with velocity maps, this represents or shows how fast the ice is moving over the entire Greenland island. And so the pink areas are where the speed is the greatest, and I'm mousing over a couple of those areas. And those are where the outlet glaciers are. That's where the glaciers are pushing out most of their ice. Up here in the center of Greenland, this is much more stable, so the velocity is significantly lower. So a velocity map is useful for researchers, especially looking for things like IceBridge data, because it shows you where the big changes are taking place. So those are the areas that you would typically want to focus in. We also have some other filters. We have a temporal filter. So right now we haven't set any time range we're interested in. But for example, if you know that CryoSat flew over during April of 2017, you could quickly narrow down to see if there was any coincident data with IceBridge associated with that. And that's what you would use the temporal filter to do. We also have a keyword search filter. So if you know particular instruments, like you can just say, I only want ATM data, then the filter will only show you ATM data. And so those are some of the mechanisms that we have available for you to try to ferret out exactly what you're looking for. Now we've been looking at the northern hemisphere. We obviously have flown in the southern hemisphere as well. And so it's a similar kind of setup. You see the continent of Antarctica, and then you see all of the flight lines for the flights that have taken place there. There's a couple of things you'll immediately notice, though. One is that it looks like all of the flights, or many of the flights, originate not in Antarctica, but out of Chile, South America. And that's primarily because of logistics. It turns out flying planes directly out of McMurdo or other bases on Antarctica is extremely expensive, and it's also limited in the number of aircraft or the types of aircraft that can actually fly there. And so for IceBridge, they found it was very cost-effective to base their operations out of southern Chile, fly over a transit flight each morning, fly around for a few hours, and then fly back home again. It made for a long day. That would be a 15-hour flight day, so it's quite an ordeal, but it's much more cost-effective than trying to get the fuel and all of the other equipment down to McMurdo for some of the larger campaigns. Now you notice I'm circling over with the mouse, there are clearly campaigns that have been run out of Antarctica. They're just not the norm. They're just not done quite as often. Another thing that you'll notice on this map is there's these circles right here, which seem kind of weird. What these circles are is they're flying what is known as the pole holes over the South Pole. So right in the middle of those circles is the South Pole. And the reason they fly those circles is with polar satellites, it's best because of the orbital dynamics that they never actually fly over the pole itself. Instead, they fly at some inclination off of the pole. In the case of IceSat-2, it's a 2-degree inclination off of the South Pole. But what that means is every single orbit, they're going to fly over some arc of this circle. And so every time it goes around, it's going to be hitting part of this. So what IceBridge does is they fly these pole holes fairly regularly because it provides good ground truth, as it were, information to help calibrate those satellites so they can compare the results that they're seeing with what the satellites are seeing. And it's a good place that you know the satellite's going to be over every single orbit. And so that's what those holes represent. But if you look, it looks very similar to what we had seen on the northern hemisphere. Over on the left-hand side, we have the list of products that are available and the same filtering mechanisms, and all of that still works. Everything persists, too. So if you draw a bounding box here in the southern hemisphere, and then you switch back to the northern hemisphere, everything is still as it was when you left it. And when you come back, it's still filtered. So we're trying to build in persistence into the system so that if you come in and put a lot of work into filtering down to just what you want, and then you get interrupted, you haven't lost that. It's still all there. And so we're trying to use or take advantage of that kind of persistence to help you guys out. Now let's assume that we've been looking around, we've been playing around with the data, and we've looked through what we might want to order, and we're ready to go order. So the way we do that with the portal currently is you click on here, up here in the left upper right-hand side, there's a View Workspace. And I will tell you, it's called a View Workspace for historical reasons. We're probably going to change that to just orders. But the reason it was called View Workspace is we intended to let you manipulate some of the persistence that we talked about. Maybe share some of your bounding boxes with other people and that kind of stuff. So we intended initially to expand what this area was going to be for. But right now, it's all about orders. And so if you remember, in the northern hemisphere, we picked some DMS images to order, and we picked some airborne topographic mapper images to order. And so here they are. They're in our box. It tells you how big they are. The ATM data is not such a big deal. It's 114 megabytes. But the DMS images that we gathered was pushing 9 gigabytes, so that gets to be pretty big. Now you can open these up, and you can scroll through and see precisely what the files are and how big each of them are. And it may be that you don't want them all, so you can come here and start deleting them if you want. And you'll notice that the size will begin to go down as we start deleting these images out of here. Not real fast, because there's a lot of DMS images. And in fact, you may say, well, that's just too big, that's just too much trouble, so we can just delete the whole set of DMS images. So now we're just left with the ATM data. And you can, if you remember, it was only 3 files, and they're not so big, so that'd be pretty easy to download and deal with. So what do you do if you want to download it? Well, the first thing you have to do is, if you're accessing NASA data, they do want you to use an Earth data login. And I apologize. I was supposed to have been logged out so I could show you how to log in. But when you click on that, it takes you to just a login screen, and you can register if you don't already have an account. And all they want to do is just be able to track metrics and see how much data is being gathered. And so once you log in, you'll notice that this page changed so that we have a number of different options for getting to the data that we've selected. We can simply go get the data, and we give you a couple of options there. You can get a zip file, or you can get the individual files. And we will stage that data for you and leave it available to you to come get for a period of time. And so that's one way to come and get the data, especially if it's a small amount, like 114 megabytes. It's not a big deal. But if you're talking about gigabytes of data, one of the better options might be to download a script, and what we will do there is we'll send you a script that you can embed into a Perl script or some Python code or something like that, so that you can go get the individual files one at a time. And that way you're not bogging your network down. You can gather it at your leisure. You can kick the thing off to run overnight to go get it, and it's just a nice, simple way to go get individual files one at a time. And if one of them should fail for any reason, you can go back and get it, and you haven't lost the entire order. So that's a pretty nice way to get especially larger orders. And we also have a couple of other options that we added. We added it kind of as an experiment, and it turned out to be easier than we were expecting. You can save it to Google Drive, and you can save it to Dropbox. In both cases, you have to have an account. In the case of Google Drive, I've already logged into that, but for Dropbox, I haven't logged in, so I would have to go to the authorization screen and have it log me in. And because I've already been there before, it remembered me, so it was able to set that up very quickly. So if I go to here, let me start that over again. So let's suppose I want to save it to Dropbox. I can just click on that, and it tells me how big, and it makes sure that that is what I want to do, and then I can just hit proceed. So it sets up an order for me, and I can come back and I can check on this order. And in fact, yesterday I was playing around. Here's some previous orders that I had placed yesterday. And so I have a history of what's going on with the orders that I have and some status of what's happening there. And so you can come back to this order link anytime you want. So I'll show you how it kicked us over there automatically, but let me show you how to go look for it. Typically, you're looking in the map view, and here's the map tab. Right next to it is the order tab. It shows you where your orders are and the status of them. So, so that's the way you can track your orders and see where things are going with that. So we've talked about finding data. We've talked about what some of the data is. We've talked about how to order it. And I hope that gives you a fairly detailed overview of how to use the portal and the types of data that are available there. I want to bring up one more topic, though, and that is I had mentioned that IceBridge was primarily being used as a mechanism to bridge the gap between IceSat and IceSat-2 data. And so we've had a number of requests to make those two products available in the portal as well. And so we've begun experimenting with how might we expose IceSat and IceSat-2 data through the same mechanism. And so one of the things that came up was these polar views that we're using will no longer be adequate because satellite missions are global in scale and not confined to just a polar view. So we're looking at taking a different type of approach and using a globe, and everybody is pretty familiar with how to manipulate a globe. And here what we're looking at is a couple of days worth of IceSat orbits along with the flight lines associated with IceBridge. And so we're beginning to experiment with letting you overlay all three of the missions so that if you draw a bounding box, you'll see not just the IceBridge data, but the IceSat-2 and the IceSat data available there. This also illustrates pretty nicely. Here's the pole hole I was talking about. So you can see with IceSat, every time it flew over, it passed this circle that we were talking about earlier. Anyway, that's where we're going. This is just an experiment, or this is in beta development right now, so I don't have a schedule yet for when this will be released, but that's where we're going with this, is to try to make it a one-stop shop for getting all three of those types of data products. And with that, that's pretty much everything I have that I had wanted to cover. So I think, Jennifer, we go to questions now, right?
Yes, okay. Well, thank you, Steve, and thanks, everybody. At this point, what we'll do is we'll transition to a final set of polling questions. And I'll probably give these, 3 to 4 minutes or so you have an opportunity to weigh in if you're interested in weighing in on these questions. And then from there, we'll go directly to the Q&A. All right. Well, thanks, everybody. We're going to hang tight for about 3 to 4 minutes here. And then from there, we'll move to the question and answer period. Okay, everybody, we're going to give this about 2.5 more minutes or so, and then we'll go ahead and move to the question and answer period. Okay, everybody, at this point we're going to go ahead and move to the Q&A period. And actually what we had was we had a polling question response that we can address now as well. And so one of the participants had asked whether or not there will be a subsetting tool for IceSat-2.
Yeah, that's a great question because IceSat-2 is going to be big, very big. And so the answer is yes, there absolutely will be a subsetting. There'll be parameter and spatial and temporal subsetting capabilities for most of the products, at least for the products that make sense. So IceSat-2 is going to represent about 1 terabyte of data a day. And so that's not something you want to download fully. So subsetting is going to be a critical component of that. We have subsetters now that work with all of the sample data that has been generated, and we're basically just waiting for launch so that the actual data itself can be regression tested through those subsetters. So the short answer to your question is yes, there will be subsetting of IceSat-2.
Okay, great. Thank you, Steve. And while we're waiting for questions to be entered here into the Q&A pod, I just wanted to draw everybody's attention to the presentation files. They are in the lower right-hand corner of your screen. If you highlight any of the files, you will be prompted to download that file. And what I did here is actually separated out the 2 videos just for size purposes. So if you'd like to download the videos that Steve showed today, you'll be able to do so below. Anybody have any questions?
I will say one of the things that I am especially interested in is how I had mentioned how big the IceSat-2 data was and other orbital missions. And it's critical that people be able to get access to both the IceBridge and the IceSat-2 data. And we're fishing around for some ideas in terms of how best to present that. So for example, with the IceBridge Portal, we show you all of the flight lines and all of the data at once. But we're thinking, like with IceSat-2, we should do the opposite, where we don't show you any of the orbits and we make you begin filtering and select the date ranges and the area. Too much information all at once. So any ideas you guys have or any suggestions you have, would be very open to hearing those.
Okay, thank you, Steve. So you do have your first question here, and that is, could NSIDC reprocess CryoSat-2 using swath processing interferometric. Such wide coverage, high resolution digital elevation models for ice sheets and glaciers sorely needed?
That is a good question, and that would be a question for basically the researchers that would be associated with that. CryoSat 2 has their own mechanism for distributing the data. So the CryoSat 2 data itself, we do not make that available. You have to go to the CryoSat 2 sites to get that. However, what you're talking about is a derivative of that. And that is indeed something that's needed. And there's a lot of work going into DEM development using a lot of different sources. Frankly, I'm not as familiar with the new DEM use, including the use of CryoSat 2 data. So the question is, yes, it's going on, but I don't know the specifics of it.
Okay, well, thank you, Steve. And maybe this is, too, a question that you could follow up with offline as well.
Sure.
Our next question is, let's see, I have a question about overlaying multiple IceBridge data with velocity. I mean, for example, to compare elevation and velocity at the same time. I'm not sure if that was very clear. I have a question about overlay of IceBridge multiple data with velocity. So I guess it is to compare both elevation and velocity concurrently, if I understand correctly.
Yeah, certainly that's doable. The velocity map that we show on the portal itself is just a map. It's just an image. So there's no values in that image itself. But the ice velocity map for Greenland is a measures product that we do host here at NSIDC, and so you can actually come and get that data and make that comparison yourself should you want to. We were primarily showing that velocity map so you could easily see where the glacier outlets were, and it'd be easy to find those locations. But measuring that type of thing would be a useful process to go through. And I know Joe McGregor and some of the airborne topographic mapper folks have been showing what's been happening with the faces of those glaciers over the past decades. And so that's where you could take that velocity map and lay that on top of that and see how that corresponds to it. But in terms of doing that in the portal itself, that's currently not a capability that's in there, mainly because we're just showing the image itself.
Okay, thank you. And then there's a follow-up here as well. There is a large quantity of CryoSat 2 data, but swath processing is taking a while, and it is not clear how much will be released and with what. Are there additional questions? All right. Well, if there are no additional questions, what we'll do is we will log off from the audio component of the webinar, and we'll leave the virtual meeting space open for another 10 minutes or so. If any of you have any questions, think of something, feel free to type that in here. By interacting with the direct link to the recording, the presentation file download capability will be is a persistent feature. So if you're interested in downloading today's presentation, the native PowerPoint files, you'll be able to do that as well. And then just a plug for our upcoming webinar, which will focus on sea surface salinity data from Aquarius, and also the MAP mission will be taking place on August 8th. And if you can check out for more information at our catalog, which is tinyurl.com, Earth Data Webinar. Let's see if we've got any additional questions here. Yes, we do. Will there be an equivalent to Arctic DEM for Antarctica?
I think so. I know that people are working on that. I don't know what the scheduled release is for that, but certainly people are looking at that. And that is, you point out a major hole. There does need to be a good DEM for Antarctica.
Okay, thanks, Steve. And there's another question. For example, using WorldView, et cetera, with photogrammetry.
Andrew, I'm not sure I understand what that means in terms of your follow-up question. Are you referring to doing DEMs for the Arctic or Antarctic with that, or I need some clarification on your question, if you could. And for those of you that are not familiar with WorldView, it's another tool that Estes has that lets you look at some of the lets you visualize some of the data and parse through it, some of the swaths and some of the imagery and stuff.
Okay, let's see here. Is there a follow-up to that? I don't see anything yet. So I'll type in the WorldView link, but I don't think, is IceBridge data available within NASA WorldView?
I don't think so, no.
I don't think so either. There's approximately, I guess we're getting close to about 700, full resolution global imagery layers that span the disciplines. So there could be some cryospheric data, but there's also, atmospheric data products, ocean data products. As well. And so I'll type that in for everybody. Are there any additional questions?
Hey, if I can jump in here. Yeah, so Andrew, I apologize. So you're referring to WorldView, the satellite, not WorldView, the viewing tool. So yeah, so WorldView was used, the satellite data was used to make the DEM of the Arctic. And yes, there is some work going on, I think primarily out of Irvine, just looking at doing the same thing for Antarctica. But I don't know the status of that. So yeah, sorry about referring to the wrong WorldView there.
All right, well, thank you for the follow-up clarification. All right, everybody, if there are no additional questions, I'd like to thank all of you for joining us today. And then perhaps we will see you again at an upcoming webinar. And with that, I'll do another check for additional questions. All right, thanks to all of you. We really appreciate it. And again, I hope to see you online for another webinar in the future. I hope to have this recording actually posted and out to everybody tomorrow. And with that, we will go off. We'll log off from the audio component and leave the virtual meeting space open. All right, thanks everybody. Thank you, Steve.
Thank you, and thanks everybody for listening.
All right, and as I always say, goodbye everybody. Bye-bye now.